Good morning, mathematicians. Today we are going to be going over inverse trigonometry. This should feel like a refresher from your 9th grade year in geometry. Don't forget to write your objective, and let's go ahead and jump in. Okay, so quick review. What is inverse trigonometry? The inverse trig functions that we're going to use are the following: inverse sine, inverse cosine, and inverse tangent. If you see here, I put a little screen grab of where those are located on your calculator. You get to them by hitting second and then the trig function that you need. So if I want inverse sine, I'm going to hit second sine. If I want inverse cosine, I'm going to hit inverse cosine, and so on. Normally we use trigonometry to find the length of a side, but inverse trigonometry is used to find the missing angle theta. And here are our ratios. You can see we have a visual display here that you'll want to copy down. The inverse trig ratios can be used to find the angle of a right triangle when given two sides. So we know we have Pythagorean theorem when we have a missing side length that we need. We have trigonometry when we have a missing side length that we need. And inverse trigonometry is the one that we use to find a missing angle specifically for right triangles. So we can see that we have SOHCAHTOA here. And then you can see how SOHCAHTOA translates over into the inverse trig function. So theta will be equal to the inverse sine of opposite over hypotenuse. Theta is equal to inverse cosine of adjacent over hypotenuse, and theta is equal to inverse tan of opposite over adjacent. Remember that opposite and adjacent will change depending on where theta is. Since theta is down in our left-hand corner over here, the opposite is going to be that leg that is furthest away, and adjacent is going to be the side that is closest to theta that's not the hypotenuse. All right, so let's check out this example that we have here. We want to find the measure of angle R. So the first step that I'm going to do is I'm going to actually label theta where R is. So I can see right here my corner R, that is theta. So I'm going to draw the little symbol for theta. So step one, figure out where theta is. Step two, just like we've done before, we are going to label. So I'm going to always label my hypotenuse first because I just prefer to label that one first. Across from the right angle, there it is. Got the opposite all the way across from theta, and then I have adjacent right here next to theta. So step one, label theta. Step two, label your sides. And now step three, we're going to circle right here, circle the sides that are given. So I've been given opposite and I've been given adjacent. So using SOHCAHTOA, I'm looking for what part of SOHCAHTOA has the O and the A, since those are the sides that I circled. And that looks like it's going to be right here, TOA. So if you want to refer back to our ratios right here, I'm going to set up the tangent ratio. So go ahead and start writing. Theta is equal to the inverse tangent of opposite, which is 8.9 in our case, over adjacent, which is 3.1. And then I'm going to head over to my calculator and type in the inverse tangent of 8.1 over 3.1. Perfect. And it gives me that theta is equal to 69.1 when I round to 3 sig figs. Now, if you've got a very different answer than that, I want you to double check that your calculator is in degree mode, because it might be in radians still if you're not getting this answer. And that would be the measure of angle R right up here, 69.1. Now, if I wanted to find the measure of angle P right here, I can do the same thing. I can do inverse trigonometry, or I could use the fact that I know that all three angles of a triangle sum to 180 degrees. And I know that one of them is 90. Now I know that the other one is 69.1. And then if I wanted to figure out that missing angle, I could just solve for x. All right, let's look at another example. Okay, so we're given two sides again, and now we are finding the measure of angle P. So repeating my steps here. Step one, I'm going to label theta. So P is going to be my theta right up here in this corner. Step 2, I'm going to label the sides of my triangle. So I've got that hypotenuse here across from the right angle, got the opposite across from theta, and the adjacent, my side closest to theta. All right, step 3, I'm going to use SOHCAHTOA. SOHCAHTOA. And let's see what size we are working with here. So it looks like I have been given H as 8.3 and A as 6.7. So let's go look at SOHCAHTOA and see what part contains both A and H. It's not SO, it's not TOA. I'm left with CA. So again, going to set up that cosine ratio over here, CA. We have theta is equal to the inverse cosine of adjacent over hypotenuse. Theta is equal to inverse cosine of adjacent, which for us is 6.7, over hypotenuse, which is 8.3. Gonna head over to my calculator and solve for that. Inverse cosine of 6.7 over 8.3. And it looks like theta is 36.2, again, when I round for 3 sig figs. And whenever you are solving for angles, I also want you to ask yourself, like, does this angle make sense? This is an acute angle, so 36 degrees does make sense for it. If I was solving this in radians or I typed in something wrong and I got a really large number, like over 90 degrees, that's an obtuse angle. That wouldn't make sense for the diagram that we have drawn. Not to say that that won't happen sometimes, but usually the diagrams are at least somewhat accurate. And if you see an acute angle, it should be an acute measure. All right, now let's look at this little bit more of a complex problem. This is a complex figure where we have 2 triangles that have been put together, and it wants us to find theta. So let's locate where theta is, right down here in this corner. Okay, so if I'm finding theta, I'm already thinking to myself, I'm going to need to use inverse trigonometry because I'm looking for an angle. Now, if I'm using inverse trigonometry, I know that I'm going to need 2 sides of this right triangle. 2 sides. That is horrible writing. Let's fix that. I need 2 sides in order to use inverse trigonometry. So if I outline this triangle right here, this right triangle, this is 8, this is theta, but I don't have any other information that can help me solve for theta. So I'm going to use the other triangle that's attached to this smaller triangle to help me figure out what this side is. Because since it shares a side with this bigger triangle over here, I can use the information that that triangle holds in order to figure out this side. So let's look over here. We've got 38 degrees, 10 degrees, and then 38 degrees, 10 meters for one side, and then X for our missing component. So if I have one side and an angle and I'm looking for a missing side, that tells me I am using trigonometry. Let me get my eraser. Okay, and let's set that up. So trigonometry, let's locate theta right here, 38 degrees. Label our triangle. I've got the hypotenuse right here across from the right angle. And this would be my opposite side because it's furthest away from theta. And then this one down here would be adjacent. Okay. Circle the sides that I need. I've been given hypotenuse for 10. I'm looking for opposite, which is X. So if I look at SOHCAHTOA, I need the part that contains O and H, which for us is SO. So let's go set up that trig ratio. Sine theta, which is 38 degrees, is equal to opposite, which is X for us, over hypotenuse, which is 10. Okay, gonna do some inverse operations. This is currently being divided by 10, so let's go ahead and multiply by 10. And X will be equal to 10 times sine 38. 10 times sine 38. Nope. All right, looks like that side is equal to 6.16. 6.16. Perfect. All right. So now that we have that missing side, remember we are not done yet. Our job is to find theta. So let's make this move up a little bit. There we go. All right, so we have this triangle down here. We are trying to find theta down here in the corner. We know that this side is 6.6, and we know that this side up here is 8. So now that we have our two sides, we can go ahead and use that inverse trigonometry. So let's label our triangle. We've got theta here. This is opposite. This is hypotenuse. So using SOHCAHTOA, it looks like I'm setting up sine again. So theta will be equal to the inverse sine of opposite over hypotenuse. Opposite for us is 6.16, just like we solved earlier, over the hypotenuse, which has been given as 8. Let's go ahead and plug that into our calculator. So we want the inverse sine of 6.16 over 8. Boom. And it looks like theta is going to be equal to 50.4 degrees. Okay, so this is a little bit more of a complicated problem. Just to recap, I wanted to find theta, so I know I needed two sides. Unfortunately, I was only given one side, so I needed to use the other triangle, this bigger triangle right here. I needed to use the information that was given there in order to find that other side. So kind of breaking this problem up into two smaller problems. I need a side, so let's go create a way to get that side through trigonometry. Now that I have that side, let's go ahead and solve the original problem of finding theta. So you will definitely see a problem like this in IB questions. They really like to break it up into multiple parts. Part A might be find that missing side. Part B then will be find theta. So just remember to chunk it up and take it step by step. All right, you are now ready to move on to the practice. Come see me if you have any questions. Bye.